All right, so for question 11, we are given the average rainfall in inches for two cities, Seattle, Washington, and Salt Lake City, Utah. And we are asked to create a dual box and whisker plot. That's just two different box and whisker plots on the same graph, if that's confusing. So before we do that, we need to do the 5-number summary for both sets of data. And I did that off screen just so this video wouldn't be super long. So remember, what we need to do first is reorder our list so that our data is in ascending order. So from the minimum to the max. And then identify the min and the max for each. So both Seattle and Salt Lake City had a minimum of 0.6 of an inch. The maximum rainfall on average for 6.5 in Seattle, 2.3 in Salt Lake City. And then we need to find our median and interquartile range. So for both of these data sets, there are 12 data, right? Because 12 months in the year. So I know like 6 of those data points are before the median and 6 after. So the median for both of these is going to be a number that's not in our data set. So you could think of it as being the median of 1.5 and 1.6 or the mean of 1.5 and 1.6. Because anytime we take the mean of two numbers, it's always the same as the median of the two numbers. That's only when there are two numbers. So we do the same thing for the first and third quartiles. So if I look at the first set of my data, I have 6 pieces of data. So Q1's got to be between 1.4 and 1.5 and so on. Same with Q3, same with Salt Lake City. So when we go to make our box plots, I did mine already. Remember, you should have the minimum. The box starts at Q1. The line through the box is the median. The box ends at Q3 and the plot ends at the maximum. And so I had to add some room to our number line since our max is 6.5. We do the same thing with Salt Lake City. So then we're asked some questions. So which city do you expect to have a higher mean? Well, just looking at this, I would expect Seattle to have the higher mean. Even though we can't tell from the box plot what the mean is, it has a much, much higher median. In fact, its median is greater than the maximum rainfall in all of Salt Lake City. So I would expect Seattle to have the higher mean. In which city do you expect to have data that's skewed? So I would be really careful here because we can't tell a skew from a box plot. We could look at our data, and what I might notice is that, like, I don't know, for Seattle, there's a smaller amount. I don't know, there's like less of a range between the minimum and Q1 than there is from Q3 to the max. So I might wonder if I've got more of a skew with that graph, but I'm going to tell you, I'm actually going to leave that question blank because we really can't tell that from a box plot. We would need to do a different analysis of our data for that. Maybe make like a histogram or something. And then lastly, in which city do you expect to have a lower standard deviation? So remember, the lower the standard deviation, we said we use that lowercase sigma to represent standard deviation of a population. The lower the standard deviation, that means that data is clustered closer to the mean. So I would expect Salt Lake City to have the lower standard deviation because I don't know where the mean is exactly, but I know where the median is, and I see that that data is just more tightly clustered, whereas Seattle has a greater spread. So I'm going to guess that Salt Lake City has the greater mean. We'll find out in a second, or the greater or lower standard deviation, excuse me. Okay, so then to complete the table, we know the medians already. We said the median rainfall for Seattle, we should find that that is 3.1 inches. That was the center of our data. And for Salt Lake City, it was 1.55 inches. But to find the mean for each of these, we need to add up all of the data from each column and divide by the number of data. So like add up all 12 of those numbers, and the answer we get, we want the sum that we get, we want to divide by 12. And so let's see, I did that out here already so that we wouldn't have to watch me enter stuff in the calculator. For Seattle, we should get 3.09. So really close to that median. For Salt Lake City, I think it's 1.53 where the 3 repeats. I'm just going to round. And then we're asked to write a statement comparing the measure of centers. So that should be pretty easy. If we're comparing the means, we could say Seattle has greater mean rainfall than Salt Lake City. And if we compare the medians, well, I think we'd be saying pretty much the same thing, that Seattle has, probably should have been a greater median rainfall than Salt Lake City. So when we write comparison statements, we could use phrases like greater than, lesser than, equal to, or we could say this distribution has this feature while the other does not. What do these comparison statements mean in real life? Well, what we would expect is that on average, we're going to get more rainfall in Seattle than in Salt Lake City. So I might write that. So on average, on average, Seattle has more rain or more rainfall than Salt Lake City. So there might be like times in the year where Salt Lake City experiences more rain than Seattle, like maybe in the month of May. Looks like they look like they're about the same in July. But I could say that on average, I'm expecting to have more rain in Seattle. And if you've ever been to Seattle, you might be able to verify that. It can be very rainy up there. All right, we've got a little bit more to talk about with this Seattle Salt Lake City question. In question 15 on the next page, we have the same data. It was just copied over so we don't have to keep flipping back and forth. We are now given the standard deviations. So for Seattle, 1.859. For Salt Lake City, 0.512. Remember, we use that sigma to show standard deviation. So what does that tell us about the data for each city?
Hello, everything work out for you on your...
Sorry, as I'm filming this, I got interrupted because this is right after our lockdown drill on Monday the 29th. So sorry about the interruption. Okay, so remember we said standard deviation is how spread out our data is from the center. It's a measure of spread, but it has to do with how far data is from the mean. And we said the greater the standard deviation, the more our data is spread out from the mean. So there's a couple ways you could answer this question, but we could say that, for example, in Salt Lake City, or rather we could say, in fact, I'm going to change this into like a comparison question. So we could say, since the standard deviation 0.512 for Salt Lake City is less than the standard deviation 1.859, and that's the one for Seattle, I know that more data is clustered close to the mean for Salt Lake City. So if we think about what that really tells us is that the mean is like a pretty good indicator of what the rainfall might be for Salt Lake City. We have data above the mean, we have data below the mean, but most of our data is near the mean. Okay, Let's see. Can we do? Yeah, I think I'm gonna just keep rolling in this next question. Okay, we're switching gears. Lisa moved to the Eagle Crest area and is looking for a 3-bedroom, 2-bath house. And below is a list of houses her realtor put together and their asking price. The realtor told Lisa that a typical price of a 3-bedroom, 2-bath house is $549,600. So the first question is, what measure of center did the realtor use to make this claim? And so if we are, the way to answer that question is to find them both. So out to the side, again, we could list all of our data. I was going to call it 450K, but then I decided not to. So if we find the center of our data, once our data is in order, so from least to greatest, that would be our median. And then if we add all of our data, and since there's 10 data, divide by 10, that gives us our mean. So that's how we know that's the mean. We don't take a guess, we just find the mean. And did I write down the right number? I think I wrote down the wrong number over here, but I do believe that the mean is 549,600. I hope I didn't make a mistake also. Okay, so then do you think the realtor should use the mean or the median when stating what a typical housing price is? Well, if we look at our data again, the mean that we got is like more of our data is above the mean than is below it. That might be like one consideration. We have a bunch of houses here that are valued for greater price than our mean, but it's like we have these lower price houses that are really driving down like that data. So if it were me, I think I would make the argument that the median is a better predictor. I might say the median, like because an equal number of houses cost more or less than the median price. And we said the median is what, 624,500? Yeah, so even though there are 4 houses that cost less than that, if you're looking at 10 houses in this area, you know, you might think like, okay, those 4 houses are going to bring the mean down, whereas the median is a little bit more resistant to high highs or low lows in our data. Okay, in question 17, we are using the box and whisker plot provided to fill out the 5-number summary. This is a good example of when we don't have a whisker on the left. What that means is that our minimum and our first quartile are the same. Now, I have no idea what this information is about the United States. There's nothing, I don't know. Is it like number of children in a household in the United States? I have no idea. So the minimum is 0. The first quartile is also 0. So this is both the minimum and quartile 1. This is our median of 2. Our third quartile is at the end of the box, so that's 5. And then our maximum is 11. So this is what we call the 5-number summary, but then we're also asked to find our range and interquartile range. So remember, our range is just our max minus our min. So 11 minus 0 is 11. And our IQR is the third minus the first quartile. So 5 minus 0 is 5. All right. I'm going to make a separate video just for this last page.